This is for Year 11 methods. It's about finding the range after sketching a restricted domain quadratic. Okay, so what do I know about this quadratic? It's a perfect square because it's x minus 1 times x minus 1. Therefore, the parabola would cut through at 1 and positive 1 and touch. And that's what it would look like if it had an unrestricted domain. It would look like this. Where that's 1 and that's 1. However, my restriction is going from -3 all the way through to 6. So in actual fact, the graph stops when x equals -3 and doesn't have anything to the left of it. And it stops when x equals 6, it doesn't have anything to the right of it. So that's going to be my actual graph. So I'd like to find out what's the y value for each of these points. Now, because I've been asked to sketch it, I'm going to put this point as being -3 and something, and this as being 6 and something, and that's 1 and 0, and that's 0 and 1, because I need to label the axial intercepts. This value here actually won't influence the range at all, because I know my range goes from 0 all the way up to this value. Okay, so how do I find those endpoints? Then I substitute -3 in. So f of -3 will equal -3 squared minus 2 times -3 plus 1, 9 plus 6 plus 1, 16. And f of 6 will equal 6 squared minus 2 times 6 plus 1, 36 minus 12 plus 1, 36 minus 12 is 24 plus 1, 25. So there's my graph of f of x. Done that. And then state the range. Well, the range of f of x will go from 0, because the lowest y value that I have is 0, all the way up to 25, and it'll be a square bracket on 25, because there's a square bracket on 6, which means x equals 6, which means y does equal 25.